Okay, so let's take a look at one more thing that we can do with interpretations, which is to demonstrate that an argument is invalid. Remember that validity in predicate logic means that there's no interpretation at all that's a counterexample, meaning that the premises are all true and the conclusion false in that interpretation. If we can find even one such interpretation, it's a counterexample. It shows that the argument is definitely not valid. Now, on the other hand, to show that an argument is valid, we can't just sit there and go through interpretations after interpretation and show that none of them work, because there might always be one we haven't checked yet. So we would have to do a derivation and provide an actual proof that the argument is valid, and that would show that you're not going to be able to find an interpretation that'll make it that'll be a counterexample. On the other hand, if you're trying to get a derivation and you can't prove it to be valid, it may very well be invalid, and that's when you want to start trying to look at interpretations and try to construct an interpretation to show it to be invalid, try to construct a counterexample. So a lot of the time, the way to start is just to look at what an argument says and think, maybe that sounds valid, I should start by trying to get a derivation. Or maybe that sounds invalid, I should start immediately with trying to generate a counterexample, and that might save you a little work. On the other hand, sometimes you just look at it and you'll have no idea, like off the bat, whether it sounds valid or invalid. You won't have any intuition one way or another, and in that case, you just kind of got to try interpretations, and you kind of have to go back and forth between interpretations and attempting proofs and see where you get stuck and see which direction you have to go. So let's take a look at this one. This says if it's S, then it's T. That's for everything in our domain of discourse, or domain of discourse. Sorry, universe of discourse. If it's S, then it's T. If it's T, then it's R. So therefore, if it's R, then it's T. Okay, that doesn't sound right. That's like saying if it's a cat, then it's a mammal. If it's a mammal, then it's an animal. So if it's an animal, then it's a mammal. And that's clearly not applicable, or that's not applicable to all interpretations. In fact, in the real world, that's definitely not true. So there's at least one interpretation that's going to make this false. So let's start trying to construct an interpretation that'll show a simple interpretation that we can describe easily that'll show this to be invalid. So one that'll make this true and this false. Okay, so 3 predicates is about the limit of this method. If you have more than 3 predicates, you're not going to be able to draw interlocking circles like this, and you may have to find some other way to reason about it than graphically like this. So usually the way to start is by trying to make the conclusion false first. We'll make the conclusion false, and then see if we can make this true at the same time. So the conclusion says for everything, if it's R, then it's T. So that's fine. Let's just put something in R here. We'll just call this thing Albert again. Okay. So Albert is R, but not T. Okay. So this is false. It's not true for everything that if it's R, then it's T. So we need to make these 2 things true. Okay, by showing that everything that's S is T and everything that's T is R. And as a matter of fact, these are both already true in this model. They're vacuously true because there's nothing in the universe of discourse that's S. So there's nothing that's S and not T. So this is true. And there's nothing that's T, so there's nothing that's T and not R. So this is also vacuously true. All right, if we wanted, we could put something else in here. say Beth. Beth is S, Beth is also T, so this is true. Everything that's S is T. And this is also true. Everything that's T is also R, because Beth is both T and R. She's in all of these circles. So either way would be fine. Let's go ahead and formally describe this counterexample, this interpretation that shows this argument to be invalid. Our universe of discourse is Albert and Beth again. What's the extension of S? It's the tuple, which is one thing in it, Beth. T is likewise just a tuple with Beth in it. And R has got two things in it, the tuple with Albert and the tuple with Beth. Okay, now you might wonder, when it's just one thing, when it's not like a pair of things or more, why do we bother putting it in a tuple? Why don't we just say, Beth is S? The reason is just to keep this consistent when we're working with predicates that might have more than one place. When we're doing logic that's not monadic like this, we might have relations in here as well, and we want to just keep things consistent. But anyway, this this is just an aid to our thinking, but this is a proof that this argument is not valid. It's a counterexample.